Algebra 1 skills number 33, using factoring to find zeros of a function. So what are zeros? Zeros are just simply x-intercepts, which seems weird to call them zeros. The reason the number 0 shows up in the name is it's when y is equal to 0. Okay, so if you think about when y is 0, you're neither above nor below the x-axis, so you're right on the x-axis, your x-intercept. Now we're going to need to know the zero product property here, which is simple. It just says if you multiply two things together, we'll call them A and B, then one of those two has to be 0. Okay, you can't multiply two non-zero numbers like 2 and 5 and ever expect to get 0 out of that. So if you see two things multiply together to get 0, then to be true, one of those has to be 0. Finding zeros algebraically. I'll go ahead and say this. If you have access to the graph on a test, don't worry about finding them algebraically. Just graph it and look at where it crosses the x-axis. But if you have to find them algebraically, do this. Set y equal to 0. Now sometimes it's f of x. Sometimes there may not even be a y. You just have to put an equal 0 on it. Factor. Set each factor equal to 0. We'll explain why. Solve each equation. So let's take a look. Example 1. Find the zeros. We color-coded this to be y. So remember, our first step is to simply set y equal to 0, which we did. And then we factored here. Factors of -8 that add to -2 are -4 and +2. Now the zero product property applies. If two things multiply to give you 0, then either this is 0 or that is 0. You can't get 0 any other way. One of these two has to be 0, since as long as we're multiplying here in the middle. So I set them each equal to 0, because if either of those are 0, then it's a true statement. Okay, now just solve both of them. So add 4 on the left and subtract 2 on the right. So x is 4 and x is -2. These are called zeros. And remember, those are x-intercepts as we'll look at the graph here. 4, -2. Now this is called a parabola. We'll get into the graphing and what this actually is later. But for now, these are x-intercepts or zeros. Okay, second example. So here's f of x. So just change it to 0. Remember also, because of this 2 right here, we're going to have to split it up like this. We write 2 parentheses, this time with a plus in between. We're going to copy the first term and copy the last term. Now to get this, we don't do the -5. To get these gaps filled, we have to multiply 2 and 2, so that 2 and that 2 to get 4. Now what are factors of 4 that add to -5? So if you want to pause and think about it, you can do that. They're -4 and -1. Okay, so I'm going to fill these gaps with -4 and -1. And make sure, of course, put the x's on there too. -4x, -1x. So if you'll notice, this line and this line, the 2x squared was retained, the 2 was retained. We just filled it with -4x and -1x. And it doesn't matter which one goes in which, but I prefer to put the bigger one disregarding sign first. It's usually easier. Now we're going to take out the GCFs. Okay, so 2x is the GCF here. Okay, remember you go the smaller exponent, which is 1. 2 goes into 2 and 4. And then here we do need to take the -1 out. Okay, there's a negative here, it needs to come out. And when you divide by -1, that will change it to minus. We need these equals. It's good that we did that. Okay, so x minus 2 is our common factor. We take it out. Doesn't matter which way these go. X minus 2 comes from these two that match, and 2x minus 1 are on the outsides. Now we set each of those equals 0, because again, if two things multiply to give you 0, then one of those has to be 0. Now let's solve them. Okay, so this one's done. Divide by 2 on this one. So 1/2 and 2. And here's the graph there, 1/2 and 2. So finding zeros algebraically.